Ladies and gentlemen, welcome to It's Rainmaking Time. This is Kim Greenhouse. I am most excited about this show today because I have been interested in the solution to dehydration. For those of you who have read Dr. Batman G's book, Your Body's Many Cries for Water, and have been told that we need to be drinking between 8 and 10 glasses of water a day or half your body weight in liquid ounces of water to stay hydrated, of course, we probably thought we were at the cutting edge of the known science. But when I watched physicist Dan Nelson on YouTube, I was so excited because I actually feel like he is a prime mover in technology and new knowledge that's so advanced and yet so simple that very few people, if any, have cracked this problem on Earth. Ladies and gentlemen, welcome Dan Nelson to It's Rainmaking Time. Good morning.
Good morning, Kim.
I am so excited. I want to cut right into the concept of dehydration and hydration that has to do with the cell wall, water molecules, and I want you to paint the picture of what we're dealing with here.
What we have to do to paint this picture is step back and look at the fundamental essence of water. We have to ask the question, really, what is water? And if you give it some thought, you'll realize that misconceptions have guided literary and scientific discourse all through history. And the problem, as I see it, lies with making assumptions about things, let's say, in this case, the substance water, whose constituent components cannot be seen interacting. Now, what we've all been taught from childhood is that the H2O molecule is involved in water. But beyond that, I was compelled to challenge all the assumptions made about water for a number of very simple reasons. I think what you need to do is somebody needs to step forward with the courage to ask questions that might be, at least seem on the surface, ridiculously simple, and actually inappropriate to the topic, but sometimes that's what it takes to make a breakthrough. So in essence, that's what I did. I came forward and I said, okay, nothing about the present knowledge of water makes any sense to me. For example, if I ask the ridiculously simple question, why is a bucket of water so much heavier than a bucket of air? None of the models I've seen of water answer that question adequately.
One would assume density would be the issue, right?
Well, density is the issue. It really is. Because if I compare, say, water to the mixture of atmospheric gases, here's what comes out of it. We'll take the H2O molecule, oxygen having an atomic number of 8 with a relative atomic mass of, rounded off, it's very close to 16. Then hydrogen having the atomic number 1 with an atomic mass of 1, rounded off. So now the combined atomic masses, we'll call that the molecular mass of H2O is 18. But interestingly, most of the atmosphere is composed of molecules of nitrogen, and the molecular mass of N2 to nitrogen combined is 28. And then you've got oxygen existing mostly as 2 oxygen atoms bonded together, as O2 with the combined molecular mass of 32. And just as an example, another constituent, carbon dioxide within the atmosphere, would have a molecular mass of 44. So all of these have a greater molecular mass than oxygen. Now why? And oxygen and hydrogen bonded together. Now why would a bucket of water now weigh so much more than a bucket of atmospheric gases? Considering the fact that water is not compressible, but we can take the atmospheric gases and compress them to many atmospheres of pressure in a cylinder. When you weigh the cylinder, by far the majority of the weight is the cylinder itself. But a bucket of water, the majority of weight is the water, not the bucket that holds the water. So I got to thinking about that, and it occurred to me that if we make the simple statement, and this is what I believe we've been doing in error for many, many decades, that H2O is water, I'm the first one that's going to step up to the plate and say, no, H2O is not water, and water is not H2O. Now, that might sound a bit arrogant on my part, but there's a very, very subtle distinction here that's incredibly important. What I'm going to say is that H2O is the construction component or the building block of water. But in and of itself, H2O is not water, because all of the models, even Richard Feynman at Caltech, in his simple little book, 5 Easy Pieces, which are 5 fundamental lectures, physics lectures, he has water modeled as independent, free, unattached H2O molecules moving randomly about like the gases in the atmosphere. Well, if that's what water was, that just won't account for the density of water, and that would strongly suggest that H2O would just be another gas in the atmosphere, and one of the lighter gases at that. So now I had to step back and say, well, there's something fundamentally wrong with that reasoning. It could not be just free, unattached H2O molecules. So what is water? Well, when I got into my research, some very interesting things popped out of it. Number one, it appears that there are 2 different classes of particle we need to consider. One is called the boson particle, and one is the fermion particle. And a boson particle, examples of that would be, say, the photon that carries the electromagnetic force. Another example would be the helium atom. And the characteristic of a boson is that the boson particle is a symmetric particle. In quantum mechanics, we have particle exchange rules. So you can exchange any one boson for another, and there's no problem. And they have an even spin integer like 0, 1, etc. And one of the characteristics of the boson is that they're gregarious. If I have a given size laser beam, Kim, I can pack more and more photons into that laser beam and raise the energy level higher and higher. But now the other particle, the fermion, an example being the electron, you can't do that. They are an asymmetric particle. They have an odd spin integer, such as the electron having a spin integer of 1/2. A fermion could have a spin integer of 3/2. And unlike the photon, they're not a gregarious particle. So if I take my lamp cord and decide to double the voltage and the amperage, quite likely I will burn the lamp cord up. I'll simply fry the thing. So they're not a gregarious particle, but the photon is. They don't mind being packed together. Well, I found in my research that the photon and fermion, interestingly, have a slightly different effect on the gravity field around them. So I was able to determine that, lo and behold, the H2O molecule is actually a boson particle. That means that they can come very, very close together. They have no problem doing that. And what happens is quite fascinating. First of all, we know that the H2O molecule is slightly magnetic. And the oxygen atom is borrowing the electrons from 2 hydrogen atoms so that it can be in its most stable state. So the 2 bond together in what we call an ionic bond or an electrovalent bond. I've even heard scientists refer to that as a covalent bond. That is not a covalent bond. That is an ionic or an electrovalent bond. So, in that state, both the oxygen and the hydrogen are in a very stable state. They're very happy in that configuration. And the oxygen bears a prominent negative charge, and the side where the two hydrogen nucleon are located bears a prominent positive charge. So you've got a little tiny magnet. Now, when they come close together, which they don't mind doing because they're boson particles, something very interesting happens. Around the particles, you have an electric force field called a Coulomb field. So your two hydrogen nucleon each would have this positively charged electric field. That's a Coulomb field. And the Coulomb field has a lot to do with determining the angle, the bonding angle between the two hydrogen and the oxygen. So normally, if you took an H2O molecule free all by itself floating around somewhere, its ground state energy and configuration would dictate a bonding angle of about 104.5 degrees. But the H2O molecule is never free and unattached. We're just getting to that point.
Right. I also want to make sure we clearly delineate the premise, the underlying new knowledge that's guiding what you're saying right now, which is that traditional water cannot hydrate the cells. From your words, from your lips to God's ears. Okay, go ahead.
We're definitely getting to that.
Okay, very good.
Now, following this reasoning, H2O molecules will come together because of very close proximity, they being boson particles, and the Coulomb field actually causes them to come together and lock into place into a position like Legos, okay, or actually more like pieces of a puzzle. And they will form tiny symmetrical three-dimensional particles called polyhedron. So water will exist as tiny particles that are symmetric, and that's the preferred state in the natural world, is symmetry and stability. So they will lock into these stable structures called polyhedron, and the size and geometry of the polyhedron is determined by the bonding angle between the two hydrogen and oxygen in each H2O molecule. So here you've got water existing as essentially small crystals. Now these tiny crystals, these polyhedron, have a nice strong attraction for one another. That's what accounts for the cohesive force that determines interfacial tension, that is, surface tension. Now that tension exists throughout any given volume of water. That's the attraction these particles have for one another, and yet, unlike a normal crystal where you've got atoms bonded into a certain geometric lattice configuration, these little tiny particles or polyhedron are free to move around one another, but they don't like to wander too far away. So that's why water has its unique qualities, its properties, its attributes. That's why moving your hand through a bathtub of water feels so much different than moving your hand through the atmospheric gases, because you're moving your hand through a collection of crystals. And that body of water, be it a bathtub or a glass of water or whatever, that volume of water actually constitutes a big composite crystal. So water's a crystal. And I knew from my work that the density unit per volume of water had to be, at least 1,800 times greater than the same unit per volume density of gases in the atmosphere. And this is the only thing that can account for that. So now you've got water existing as little tiny particles. And now, when it comes to hydration, we ask ourselves, how big is the particle?
Wait, before we get to that, I just want to clarify something. It doesn't matter whether water is a liquid or ice. It's still these little tiny crystals, is what you're saying.
That's right.
As particles.
Yeah, as ice, these little crystals tend to move into a solid lattice. Okay?
Okay.
Now, people often think water has three phases. It's liquid, solid, and gas. Well, I differ with that. Water does not have a gaseous phase. Now, it goes into the atmosphere as little tiny liquid droplets. So water only has two phases. Water is a liquid because of this particle characteristic and the structure of the particle. So water is either only a liquid or it freezes into the solid phase of ice. But it does not have a gaseous phase. So now we have something to use as a benchmark to understand the problem of hydration. Why is everybody on this planet so terribly dehydrated? My fascination with that actually started 30 years ago, meeting a woman who was actually, and I have no earthly idea of how she did this, but she was drinking 2 gallons of water a day, in the mistaken belief that the more water you drink, the more hydrated you become. We were able to determine that this woman was just as dehydrated as people who drank no water at all and were trying to hydrate on coffee, tea, juice, and pop. Now, what a mystery that is. If you're drinking 2 gallons of water a day and you're still dehydrated, what does it take to get hydrated? Well, it turns out that it wouldn't have mattered how much water she had been drinking on a daily basis. She would have still been dehydrated.
Well, I drink between 10 and 12 glasses of water a day. I still feel dehydrated when I go to sleep. What is it about the water we're drinking, whether it's her 2 gallons or my 10 to 12 glasses of water a day? What is it? What is the problem?
Well, here's the problem. A man who is a physicist and a chemist, and I won't use his name, was very curious about my water, so he approached a PhD in microbiology at a college and twisted his arm. And the guy finally relented and agreed to devote a Saturday to analyzing my water. So it was a good opportunity for some graduate students to come in and get some extra work done. So the gentleman in question here, the physicist chemist, his girlfriend was a brilliant mathematician, actually a savant. And he had partners that came all the way from Singapore for this Saturday. And then there were some other people I know. And unbeknownst to me, he had set up a control situation. Now, I'm not a biologist. I'm a physicist, but in biology, when you do double-blind studies and so forth, you need some type of control, some kind of standard against which everything else is analyzed.
And by the way, what area of physics are you trained in?
My specialty is quantum mechanics. I work with theoretical physics, and I'm also lapping over into the area of experimentalists, so I have to design my own apparatus sometimes and do all the footwork to get them built, make sure the machining is done right and so forth. And we'll get to this later,
okay.
But to engineer water, I found out that water could be engineered. I had to develop a special laser, which was developed about 23 years ago. It's the only laser of its kind in the world. But we're jumping ahead of ourselves a bit here.
Well, not necessarily, because I want the audience to have a frame of reference for you. Okay, go ahead. You're talking about the control study.
Yeah, the control study. Okay. One of these individuals was drinking my water on a daily basis. The others were told to quit drinking my water 4 weeks ahead of this Saturday when they were in the laboratory studying my water. So I was given a call early Saturday morning, and this microbiologist asks me, well, how do we study your water? How do we analyze it? I said, you can, I know some people there are drinking my water. You can analyze blood. You can take a look at live blood. So he said, what do we look at? Platelets or RBCs? I said, take a look at RBCs, red blood cells. Then he said, what else should we do? I said, well, we need a membrane. We need a membrane where the orifice or hole through the membrane is of a known size. We need to know how efficiently the water passes through that membrane. He said, well, the ultimate membrane is the wall of the cell. So he said, we'll do standard absorption tests. So in the standard absorption test, they took cells that had been dehydrated with saline solution. And they put the cells on microscope slides, according to my feeble understanding of this. And you can't see where water goes. It's clear. So you have to add a dye to the water. You have to stain the water, as it were. And the dye is made up of incredibly small molecules. They have no trouble whatsoever getting across the membrane wall of the cell. But that doesn't mean the water particles are capable of doing it. So in these standard absorption tests, they compared my water to 3 other samples of water that were filtered in 3 different ways. When they put these 3 waters on cells under microscopes, the physicist chemist said, well, I've never done standard absorption tests. Now tell me, what are we expecting to see here? And the microbiologist said, oh, nothing. He said, it'll take hours for those waters to show any significant sign of hydration. So the chemist-physicist says, well, we don't have time for that today. We're here to study this man's water. Let's get it on a slide with some cells. So when they put my water on the cells, he started a timer, stood back, and a very peculiar look crossed his face, and he lunged forward and hit the timer. And the physicist chemist says, what happened? He said, did you see that? He said, that cell plumped up in a mode of total hydration in 10 seconds. He said, that's astonishing and amazing. Nobody in history has ever seen water do this. He said, well, let's do it again. So they did it again and again. They got the same results every time. The cell would literally suck the water through the aquaporin channel on the membrane wall, and it would go in and hydrate the cell in about 10 seconds. Now the question becomes, well, is there any danger of this type of water overhydrating a cell? And the answer is no. A cell knows how much water to take inside and has a mechanism for stopping more water from coming in.
Dan, what is that mechanism?
That mechanism, of course, has to do with the pressure inside the membrane wall created by the water itself, the existence of the cytoplasm. So it shuts off. There's no more hydration. It's got everything it needs. And subsequently, I had a PhD in biochemistry perform a similar test, but instead of using the kind of cell that the microbiologist was using, which is a plant cell, I believe it's a species of algae, he was using tissue from beef, pork, turkey, and chicken. And under very carefully temperature-controlled, environmentally controlled conditions, he got fresh tissue. He knows how to do the thin slicing. He knew how to prepare the slides. And he compared my water to 19 other supposed high-tech waters on the market. What he told me was relatively interesting. He said, and this was kind of funny, he said, now don't get a big head about this. I said, okay, I won't. He says, all 19 waters took a minimum of 3 days to show any significant sign of hydration. He said, your water went through those tissues and completely hydrated in 10 minutes.
And this is exactly why I wanted you on the show, and I want people to understand that this could hydrate people that are chronically thirsty in developing nations, in all countries of the world, in all locations of the world. and we could actually end up using less water to hydrate the public.
Yeah, yes, we could. Yeah. What I had to do is, with a new insight on what water is, I had to figure out the engineering solution. Can water be significantly changed? Can it be engineered so that the water particle is actually small enough to efficiently go through the aquaporin channel on the membrane wall of the cell? And the answer to that is yes. But you cannot use a conventional laser, because the conventional laser, no matter where it operates in the electromagnetic spectrum, okay, from infrared to ultraviolet, okay, is going to that photon particle wave is going to interact with the electron shell. You can't engineer water if you do that. You have to go through the electron shell, and you have to interact with the proton. You have to be able to change the Coulomb field, okay? So if you can pump energy into the proton, you can increase the strength of the Coulomb field. That is, you can manipulate the little, positively charged field around each hydrogen proton. They will repel one another, and you can increase the bonding angle. If you know what you're doing, the optimum bonding angle that you need to achieve is 122 degrees. At 122 degrees, all of those H2O molecules will quickly come apart and reassemble as a smaller particle with a different geometry. And interestingly, the way it turned out is the number of H2O molecules that will lock into place to form these smaller particles is always divisible by 4. So the smallest possible water particle would be a tetrahedron with 4 H2O molecules. Another would be a slightly modified octahedron, which is a cube with 8 particles, and the next one would be a dodecahedron with 20 particles. So all my water is made up of those 3 fundamental polyhedron shapes, and the particles actually average in size less than half a nanometer, about 0.4 nanometers.
Now, are you decreasing the molecular structure of the water?
No, we're changing the molecular structure by altering the bonding angle between the 2 hydrogen and oxygen.
Okay.
Now, when you change the molecular structure, then what you get is a subsequent change in the particle size and geometry. And the particle size goes way down into the sub-nanometer range from where it normally is, quite large. We were able to determine that some of the available drinking water on this planet actually is made up of particles that are a micron in size, 1,000 times bigger than a nanometer. So that's why you can't hydrate. You're drinking water that just can't get through the membrane wall of the cell. So all the water you're drinking, instead of hydrating, it's actually kind of irrigating you. It's going into your stomach, into the intestines, being taken to the bloodstream, and actually going right out through the kidneys. So when somebody, there was an incident not too long ago, I believe it was 2 to 3 years ago. It was a hazing incident, a fraternity hazing incident, where a young man was told to drink like 5 gallons of water in a short period of time, and it killed him. He died from water toxicity. What it does is destroys the kidneys. The kidneys fail. They can't handle all that. So the more water you're drinking, the harder it is on your kidneys, because the kidneys are actually overworking.
Let's talk about in the meantime. 99.99999% of the world does not have your water. So in the meantime, though, most people aren't doing what those hazing students did. They're trying to get in their 8 to 10 glasses of water, if that. So that's kind of the best that we have to work with at the moment until we're using your water. Now, can you tell us the size particle of your water?
Well, the size particle of my water is less than 1/2 a nanometer being a billionth of a meter. So my water particle is getting down to the size of, not much bigger than most molecules. water that people are drinking is made up of particles much larger. In fact, I worked out equivalencies, and drinking 8 ounces of this water will hydrate you as efficiently as drinking well over 300 gallons of normal water. And the reason why is because normal water always has a certain percentage of nanometer-sized particles in it. They're not all very large particles. Some of them, they're nanometer in size. So the nanometer-sized particle has to find an aquaporin channel, and that's just kind of a probability calculation in itself. So if you factor that in, a lot of waters are 2 to 3, and a very good water is about 5% composed of nanometer-sized particles. But will those nanometer-sized particles actually come close enough to an aquaporin channel to find their way inside? Not all of them will. So standard water seems to be a fraction of 1% efficient at hydrating. Now that's why the medical doctors I work with and PhDs in biochemistry all say the same thing. The major component behind the aging and dying process is dehydration. We're dehydrating to death.
I want to ask you a philosophical question for a moment, if you would. What about people that would say, obviously in rivers and aquifers and lakes where water comes from for drinking, the particle size of water is what it is, quote, that's what God gave us. So why isn't what God gave us able to get through the cell walls and hydrate us at a cellular level? Some people may think that. What do you think?
My answer is, are you sure that's what God gave us? Now, let's step back here. This is interesting. In your environment, you have this coefficient of thermodynamic efficiency within your environment.
What does that mean?
Well, it means that, every particle of mass actually derives its ground state energy from interacting with what we call zero-point energy.
Is that free energy?
We live in a universe, it's an incredibly dense sea of virtual particles. And all particles of mass derive their ground state energy, and therefore the ground state electrochemical potential of all the interacting molecules in the tissues of our body also derive their ground state energy from interacting with zero-point energy. So now, can we really make the assumption that zero-point energy has been, as it were, a constant? Has it had a higher coefficient of thermodynamic efficiency in the past? And I think it has. I don't think water has been the same down through history. And I think at this point in time, the thermodynamic efficiency of the entire environment has been degraded. So water is the first thing to reflect that. In fact, there isn't anything I know of more sensitive to it than water. For instance, you've probably seen Dr. Emoto's photographs of water particles in a frozen state.
Yes, indeed. And we interviewed him from Japan about 9 months ago. Why is that important, for example, to the work that you're doing?
That's important because what you're looking at is something most people don't understand. It began way back with the work of a man named Lorenz at MIT, the first to do computer modeling of weather systems. And what we discovered, a weather system depends not just on water, but on other conditions, atmospheric pressure, temperature, and some other factors. But what you're seeing is the fact that water is incredibly sensitive to initial energy conditions. In fact, there can be a quantum fluctuation in initial energy conditions, and that's what I'm talking about in terms of this coefficient of thermodynamic efficiency in the ecosystem that is in 0 point. Water will tell us a lot about that coefficient of thermodynamic energy or efficiency, and that's what Emoto's particles show you, is that even a prayer or a thought, i.e. your intention, will actually change the ground state energy, and you'll see a completely different outcome in the formation of those particles into a solid crystalline lattice. People don't understand what they're seeing when they see Emoto's photographs. It's just telling you how sensitive water is to the background energy state, and your field of consciousness and the thought, being either positive or negative, will have a profound effect on water.
That part was very, very clear in his work and so profound. The whole world needs this knowledge and the ability to do what you're doing with the water. Can you talk a little bit about what you're doing with the water, besides getting it to such a small particle size that it can enter the cell wall?
Well, as I mentioned earlier, I had to develop a laser that will allow me to pump energy into the proton. A proton, it seems, can charge like a capacitor, and I can manipulate the strength of the Coulomb field. So when I do that, I can change the particle size. So now I've got water, what I call a permanent high molecular spin state. It's very stable, by the way. About the only thing that can change that is exposure to microwave. You just definitely want to keep this water away from microwave. But we've been able to determine that the water in this high-spin molecular spin state will actually bend and curve space-time around itself, and that can be detected all around a bottle of this water to a distance of 4 miles.
I don't want to lose the audience because this is beyond Star Trek: The Next Generation, if you know what I'm saying. I want to go a little bit more in what the public can contain at the moment, and then if you want to go back, that's fine. And I want you to talk about the detoxing phenomenon that happens with your water, and I also want you to talk about the chemicals in traditional water and the practical use of your water. Can you do that?
Yes, I can.
Okay.
Yeah. Okay, in a practical sense, you can take 1/2 ounce, which is a tablespoon, of this water and completely change the structure and size of all of the particles in a gallon of water. Okay, the energy level is not quite the same, but it doesn't need to be, because when the water is made, I calculate the energy level so that if you get a standard 500 milliliter bottle, which is 16.9 ounces, you can make about 33 gallons of water with this bottle of water, and the energy level is appropriate. Now, the water does not just consist of smaller particles, which are more hydrating. There's more to this water than I generally talk about in public. The water actually has several elements on the periodic table encoded in it as their mathematical analog. And the water will actually mineralize the cell. It doesn't produce the electrolytic class of minerals, but it provides the cellular nutritional form of mineral as the mathematical analog, the waveform. And not only are these elements in the water, but it's the ideal isotope of the elements that have been put into the water. For instance, what do you have, about 18, 19 isotopes of iron? And out of those 18 or 19 isotopes, there's only one isotope that's friendly to the body, and that happens to be iron isotope 57. You can learn about these isotopes if you go to the publications of the U.S. Atomic Energy Commission. You don't get them in a standard college textbook on chemistry, so you'll find that the water contains the ideal isotope of iron, as well as silver, and believe it or not, tin, and all the other elements that the cells really need. But keep in mind that I've learned from talking to people with PhDs in disciplines like biochemistry that a cell will not take a mineral particle through the membrane wall inside. It has no provision for using it or attaching it. The cell just wants to be exposed to the energy, that is the frequency of the mineral, and those are the proper forms of these elements are what we get from plants. Plants are designed to concentrate the correct isotope of different minerals and deliver those to the mammal kingdom. So I provided that in water. So people can get on this water. Like women have noticed a big difference in the quality of their hair. Their hair will grow faster. The quality of their nails, fingernails, toenails, quicker. They grow quicker, harder. They're not as thick. They're thinner and pliable. They don't break as easily. So we have evidence of correct mineralization here. So we have a water that will efficiently hydrate. You can completely hydrate to take care of your body's needs for water by drinking 16 to 24 ounces of the mixture. That is where you put a half an ounce, which is a tablespoon of this water, into a gallon. And one of the things you have to watch for is when the cells begin to efficiently hydrate, there's something called the mitochondrial oxygen cycle. If you take a glass of my water and very carefully look, bring your eyes up close to the outside of a glass with my water in it, you'll notice a lot of little tiny bubbles on the inside of the glass. And those are actually not oxygen. Those are additional hydrogen. What the mitochondria in the cell needs to produce adenosine triphosphate is the hydrogen ion, the hydrogen nucleon. So when this water gets inside of the cell and hydrates it, it also takes in a lot of extra hydrogen nucleon. Then the ATP is produced in the mitochondria in abundance. The energy level of the cell goes way up. Now you've got all the ingredients for a good detox. You've got the energy of the cell raised to a maximum level. You've got it adequately hydrated. So what the cell will do, it will now purge. Out will come the poisons. So when we start people on this water, there's a ramp-up schedule. I just don't want to spin them into a nasty Herxheimer. That's not necessary. But they're probably going to go through somewhat of a Herxheimer. I had a man recently get on my water, ignored my instructions, called me, and said, I've never been constipated in my life. What's wrong? I said, how much water are you drinking? Well, he went right on up there. I said, no, you have to back off because that's a sign of detox. It can manifest as constipation. It can manifest as diarrhea. It can manifest as all the symptoms of flu, cold. You can have rashes break out. Any number of indicators of detox, including extraordinary fatigue and tiredness. So in this water, you probably, for the first couple of weeks, you're going to drink like 4 ounces of the mixture twice a day and leave it alone. And you can drink as much other water as you want. And you just need to keep it away from this water. Let it do what it does best. Get in and out of the stomach, into the intestines, so it can get into the bloodstream and efficiently hydrate the cells. Then for the next 2 weeks, you'll go up to 6 ounces twice a day. And then after that 2-week period, you go up to 8 ounces twice a day for another 2 weeks. And at the end of that time period, you've been on the water for about 6 weeks. And you can go ahead and experiment with 24 ounces a day, 3 8-ounce glasses. And by that time, people that have been drinking a lot of water have noticed that they've lost the desire to drink all that water. They're taking care of the thirst response. And I've had a lot of people drinking over a gallon of water a day, and in no time they tell me, well, I'm good to go on maybe 16 ounces of your water a day and really have no desire to drink more water. Well, that's because you're efficiently hydrating for the first time.
The distinction you made early on between irrigating your system and hydrating are very different. That's so clear now, listening to you.
Yes.
Totally different. Irrigating the organs and cells, but not hydrating. Totally different. That's a great distinction.
Yeah, and there are limitations, of course, to how much water anybody can drink in a day, because when this woman was drinking 2 gallons, I asked myself, how did she have a life outside of the bathroom? Do you know what I mean? I'm serious. I tried because of what the doctors were saying, and they had no empirical evidence for this. They just knew water must be, it's important to biology. It's based on water. So they were saying drink 8 glasses of water a day, 10 glasses, whatever you can get in you. Well, I would get up to 5 glasses of water a day. I couldn't get out of the bathroom. I couldn't understand how this woman could hold that much water in her body without spending all day in the bathroom, but apparently there was a different set of dynamics going on with her than most people. So how would you like to just be able to completely hydrate on like 16 to 24 ounces of water a day and not have to worry about slamming all that water in you?
Now, is your water something we have to keep ordering? What is the standard for people with the number of gallons that they're doing mixtures with?
When I send a bottle of water out, I send a sheet of instructions on how to mix it, and then the ramp-up schedule, how I suggest they begin drinking it. And if you can test what we call intracellular hydration versus, that's water inside the cell, versus outside, which is extracellular. And somebody on my water, let's say my age, okay, I'm 65. Now, if you put me on a really, really well-designed and accurate bioelectric impedance analyzer, you'll find I'm right around 98 to 99% intracellular hydration. Typically, somebody my age will be down in the 20 percentile and 30 percentile range.
Absolutely. I see it in the elderly all the time.
Yes.
My mother had Alzheimer's, and she was dehydrated beyond measure all the time. And, of course, once you're not in charge of yourself, it's even harder to hydrate.
Right, yeah. And at my age, I know it's made a huge difference. I never get sick. As a matter of fact, I'm not very big. I'm only 5'7". And
yeah, but you're locked and loaded. I saw you in video. You're pretty strong.
Yeah. I was handling 655 on my back for squats, and I have no knee trouble and no back trouble. I don't even wear knee wraps, and I don't wear a weight belt when I squat.
You had pancreatic cancer and a brain tumor?
Yeah, this is going on 24 years.
I want you to speak a little bit about that. That is the most magnificent thing that you have gotten through that.
Well, I was deathly ill. I can't even describe in the English language the abdominal pain and nausea I experienced. I would hit the carpet writhing around in convulsions. It's good that nobody was here to see me do that. It would have been quite frightening, and then I would pass out for hours. That's the only way I could deal with it. And I finally decided to deal with it instead of taking the recommended medical route. I did it alternatively. I used herbs at the time, and we were able to determine that I had a pancreas full of the same flukes that Hulda Clark suggests are responsible for most liver cancer, phosphopsis. I had a pancreas full of those. So with herbs, we were able to drive those out, and within 3 weeks, I was symptom-free, and I've never had a problem since. But later on, I was going blind in one eye, and I had a tumor wrapped around the optic nerve at the back of the brain, and they used a laser to deal with that. So anyway, I've had my own scrapes, and I've had a history of horrible back problems. I no longer have any back trouble. I no longer get colds, flu. People come to me all the time sick with the cold and the flu. Never touches me. And you'll find that the issue of pH is very, very critical. It's very important. But here's the important thing about pH, Kim. If you're in a dehydrated state, you cannot become adequately alkaline. It is impossible, even if you're drinking water that's been ionized, so that's alkaline anywhere between a pH of 9 to 10, you still won't get adequately alkaline. You have to be in a hydrated state. And that ionized water, alkalized water won't hydrate you any better than your tap water.
That's really profound. You know, I found out a couple of months ago that a lot of the machines, lo and behold, that are making the alkalized water actually electrocute the water, and there's other problems with the water itself. I was told that you can't really live on water that's 8.5% ongoingly, that it puts you in a clinical state of detox. Do you agree or disagree?
I agree. And it's not necessary. This water comes from the bottling plant with my energy in it, has a measured pH of 7.4, but the ultimate pH is determined by the water you mix it with. Obviously, there's only a tablespoon of this going into a gallon, so The rest of the gallon determines the pH.
Right.
But I'm finding that regardless of the final pH of that water, I maintain a pH of about 7.2, which is ideal. It's all of the organisms, the pathogens that create problems with the inside of us are acid-based. They're what you call a spin-up state. I don't have an environment that's conducive. So in reality, I don't believe we catch disease. I don't believe we catch a cold. I think we create the conditions for the disease. And alkalinity is a major part of that. If you're acid, you created the conditions for these organisms to come in. If you're alkaline, you don't provide the right conditions, they will leave you alone.
Let's talk a little bit, if you don't mind, about the reality of what is being done to most of the water that people are drinking and the chemical dumps that are now in the water, chlorine, fluorine, and worse, that many people never can filter out and never filter out enough of what's going on, and every district is different. What do you have to say about your water and water mixture vis-a-vis the toxic chemical dump that's now in our drinking water?
Well, the water I sell, of course, is an incredibly pure water. It goes through 4 purification processes. When it comes to you, it's incredibly pure. But you get out there and I ask people, what are you mixing this water with? And a lot of the tap waters, I think the thing that frightens me most is the fluoride.
Right.
I really do. I once got a phone call from a nurse living in northern Israel. She was in her mid-30s. She told me she's dealt with fibromyalgia and a lot of pain and discomfort since her teens. So for about 20 years, she's had fibromyalgia. She said, I'm finally getting a handle on this. She said, I'm going outside of town and getting water from a man who gets his water from a spring. And she says the symptoms are abating. She said, do you remember the anthrax scare after 9/11 in your country? I said, yes. She said, what did they give those people? Now, this is a nurse, a registered nurse, telling me this. I said, gee, I don't remember. She said, Cipro. Remember Cipro? I said, yeah. She said, did you know that all those people came down with fibromyalgia?
Oh, my God.
Cipro is full of fluoride. It's just fluoride poisoning. So she said, in Israel, we fluoridate the water supply as aggressively as you do in the United States. So I tell people, please try to find a fluoride-free source of water for my energy, to seed my energy into. Now, if you want to use distilled water, keep this in mind. If water cannot pass an electrical current, your body cannot use it. Daryl Stoddard down in the Provo, Utah area wrote a book called Pain Free for Life, and he was onto that. In fact, we had a nice discussion on the phone one day. You have to drink a water that has ions in suspension. Your body doesn't utilize those minerals. It has no other use for those minerals other than for their ionic properties to pass current through water. So if you're going to put my energy in distilled water, you have to add some ions back, like a really high-quality sea salt, or even, say, Bragg's apple cider vinegar will also work. But you have to have some ions in suspension, or the body can't use that water.
Okay, that's really helpful. That's really, really helpful. In terms of the clinical harm that the other toxic chemicals, besides fluorine and fluoride, what about chlorine and other chemicals that are in water? Is that going to then bring those chemicals into the cell wall quicker? What is the potential outgrowth of that?
Well, we had something strange happen, and I still have no adequate explanation for this, but a gentleman I helped years ago seed my energy into his 750-gallon hot tub. And a year or two later, he had me come out and put on a workshop and said we were going to go hot tubbing at his house. And I'd forgotten all about his hot tub containing my water. So when we did go hot tubbing, it was quite literally amazing. It was like slipping into liquid silk. It didn't feel like water at all. But he told me a strange story. He said he has a filtering system where the water is continually drawn down, sucked into through a filtering system, a series of filters, and then through a clear acrylic tube with UV light around it. So he doesn't have to use any chlorine or bromine. But every year they would come in and replace the filters in the water. He said when it came time to replace the filters, there was nothing in the filters. They looked like brand new filters.
Wow.
So now we had done some tests on the water, and we added it to highly chlorinated water, and within 10 minutes we couldn't find any chlorine in the water. In fact, we couldn't find any harmful chemicals. Now, I'm not going to make any claims about this. I'm just going to say that I recommend you get a good quality spring water. If you're going to use your tap water, get some type of decent filter. There's one I know sold by Target called a Zero filter.
It's called what?
A little Brita filter will work. But try to clean your water up a bit before adding mine water to it. But you're right. If anything's in the water, it'll take it through the membrane to the cell much easier, particularly if the molecule size is small enough.
Right. We have to do our due diligence on the front end, and it should not be the kind of water that has nothing in it. That's a very critical distinction. You had said something in one of your YouTube videos where you talked about the receptor sites, that the cells are drowning in their own waste and that they're dehydrating to death in the typical state in which we normally, I'm going to say, irrigate to make the distinction rather than hydrate. Why is that?
Well, it just simply goes back to the fact that the cell can't get an adequate amount of water inside. If it can't do that and the energy level is too low, the cell doesn't have the energy and it doesn't have the fluid necessary to keep itself clean. So all of the byproducts of metabolic activity, a lot of them hang back inside the cell. The cell can't get rid of them. So the cell literally sits there and drowns in its own waste byproducts. You know, that I don't know if you were aware of an experiment that was done in Japan years ago, but they were keeping tissue from the heart of a chicken alive in water, and the key was to change the water and put the cells to tissue in clean water every day. And that went on for literally hundreds, if not thousands, of cell replications before they got tired of doing that. I think they kept those tissues alive for an amazing 23 years or something like that. And then they just quit changing the fluid, let it get dirty, and the cells died. They choked in their own waste. So if we can keep the cellular environment as clean as possible, help the cells keep the internal environment clean, I think the impact on the genetic material in the cell is far less. I even think I have some tantalizing evidence to support this, that the length of the telomeres, the reduction in the length of the telomeres can be slowed down by making sure that the cell is adequately hydrated. I think dehydration has implications in how quickly the telomeres degrade.
You said at room temperature, human beings are superconductors.
Yeah, that was, I have a good friend in England. He actually built these things called squids.
Yes.
Okay, the superconducting quantum interference device. He built them. He was a brilliant man. He was a child prodigy. I've been told he's the brightest man in all of Great England, just a brilliant man. And we talk on the phone all the time, sound like a couple of children. But it turns out that the U.S. Navy at some point in time was using the squid with humans. It's an incredibly sensitive coil device using superconductivity, and they found that the human brain tends to superconduct at room temperature. So, say the energy moving through the neural system actually very, very similar to the energy moving over a superconducting conductor. And that I found fascinating. And I actually believe that in all cases, hydration of a biological entity, whether it be a single cell or something as complex as a human with multiple cell colonies, is the key to the efficiency of all of these things. All of the neural activity is much more efficient. Everything that goes on, the interaction, I believe the water actually extends its capabilities to 0-point energy around and through the body. So the water actually sits there and plays a role in modifying the coefficient of energy of 0-point energy in and around the human body, so that everything can tap into a more efficient thermodynamic coefficient of energy in the environment around and through the cells.
The other thing you talked about, which I loved, was that the correct application of the correct principles is what's going on here, which I thought was brilliant. And I want you to talk about something that all of us can do. I'm very much into as much practical solutions as we can do in the day-to-day. While many of us will have to wait for your water, not everybody in the world will be able to get it. But I want you to talk about hydronium and the fact that the brain is 93% water and that we must replace it. Talk about that.
I actually was able with my laser to produce hydronium. And there's a company in Grass Valley, California, was making a very complex natural acid solution. It was like, I think it was H904 or H905, and in a diluted situation, it became hydronium H3O. And so the brain, more than anything else in the body, needs hydration. It's about 90% water, and its operation is highly dependent on water. Now, this is going to sound a little bizarre to most people, but in the English language, which is based on roots primarily from Latin and Greek, we have a word for information storage and retrieval, and the word is memory. And memory is made up of two roots from Hebrew. Mem is water, and ori is light, water light. That's kind of interesting. Somebody had insight a long time ago into the nature of the brain. I believe that in my own personal work that the brain actually contains no information whatsoever. It's like the processor on the motherboard of your computer. But that's not where the data is stored. The information is not in the processing chip. It's on the hard drive or in random access memory. I believe the brain is the same way. It's just a processor, and the information is in a field around you, like a holographic field, a three-dimensional hologram. So I believe that the efficiency in terms of the brain's ability to interface and communicate with the nature of that energy field depends entirely on water. I don't think it can happen without the mediation of water.
Now, what happens at night when we're sleeping? What's going on with the brain, and why do you say we need 2 glasses of room temperature water upon waking? First thing, why?
Well, one of the things you want to do, I think some of the research that's been done, in my mind, tends to prove that one of the reasons we sleep is because mental activity produces quite a toxic level throughout the day, and at night you need to dissipate that level, and in the morning, that's when the brain needs water or hydronium to hydrate on. And a very, very good time to hydrate, probably the best, is first thing in the morning, at least a half hour before putting any food in your stomach. Let the water get out of your stomach into the intestines so it can get into your bloodstream and begin to hydrate the tissues. The brain is the most important thing. Body doesn't work without the brain, works better with an efficient brain. Case in point, recently a little girl in England who got a little over 2 years of age, got her inoculations, her immunization shots, ended up totally paralyzed. And she was dying. All the systems in her body were shutting down. So she wasn't getting any nerve energy down the brain stem to the rest of the body, so it cut the head off from the body. And the body can't live without the brain. So an efficient brain means an efficient body. And in turn, that level of efficiency allows for even more efficient hydration. So it's kind of a feedback process.
I want to talk to you a little bit about the meridian channels of the body. I think someone was talking about supplements and energy saturation and water. And you were saying that energy saturation is the perfect delivery system. Do you remember that?
Yes. Water is the perfect delivery system for energy.
Okay.
Water has a memory.
Right.
For example, when water is made up of really tiny particles, where's the information stored? Well, the particles no longer move randomly. They de-randomize and begin to move in fractal patterns. The movement of the particles in fractal patterns is dictated by zero-point energy around those particles, but in turn, the information is actually stored in zero-point energy, and the water is capable of making that energy or information. You got to understand, when we highly cohere or structure energy, we're dealing with information. So that information becomes available to the all of the particles of mass in the body. So we've got water here capable of holding, well, potentially an infinite amount of information.
In one of the YouTube videos, you said water is a menu of energy for the body. What does that mean?
Well, it is. I can put a tremendous amount of nutritional energy or information in water, because that's all nutrients are. Energy is, in the first place, is little energy packets. That's all nutrients are. It's just the delivery of certain types of energy to the body. In reality, we're nothing but an illusion. Albert Einstein said that we're an illusion, albeit a persistent one. And the only thing we really need delivered to us is energy. So, as you know, there are people they call breatharians that don't eat.
Correct.
They live on air and breathing air and drinking water. So now that begs the question, what really are our needs? Well, I think food adds an interesting dimension to the human existence. I enjoy eating. But the problem is we're eating the wrong things, and we're eating too much of the wrong things. The breatharian is proof of that. So what our basic needs are often confused with our desires. So the need for food is there, but everybody has the desire to eat the wrong foods and too much of them. So actually the nutrients are a form of energy. The ideal delivery system for the right nutrient energy would be water, because the water could take the energy right inside the cell. And that's pretty much ideal. As the biochemists say, the cell is not designed to take a mineral particle to the membrane wall. It has no provision for attaching it or fixing it. It would not know what to do. In fact, that mineral particle would just become more debris that the cell has to get rid of in terms of cleansing itself. So the cell just wants to be exposed to the energy, and that's what nutrients are. It's just energy packets.
Absolutely fascinating. You also said, and I hope I'm not taking this out of context, but you were talking about the meridian channels, and you said they do not distribute energy. They bring in information like a fiber optic cable.
Yeah.
Talk about that for a moment for the people that are aware of the meridian channels, who have done Qigong or Tai Chi, and what does that mean?
Well, all of biology, if you step back as a physicist and look at biology, and let's say you're having a conversation with a biologist, a microbiologist, a doctor, and you give your views on what biology is, what life is. To me, as a physicist, their definition doesn't make a lot of sense. So to me, life is defined as a highly ordered replicating system. And the key word in that statement is replicating. To replicate means to copy or duplicate. So if I want to copy something, say, make a new cell to replace an old cell, I have to bring all of the information from the original to the new generation, to the new copy. I can't leave any information behind. If I do, that copy is not as good as the original. So we are actually a mathematically based information system. Everything about the human organism tells me that it's entirely based on information. And the same thing that happens to your computer, to use the computer analogy here because it is valid, if you pick up a virus in your computer, what the virus is doing is corrupting data. It can corrupt you. It can wipe out your hard drive, corrupt your files. It's just a corruption of data or information. That's what's going wrong with us. A disease state is just the cells losing unimpeded access to correct information. Things are happening as to distort the information, degrade the quality of the information, or block the cells from getting the information. So, if you want a concrete example of that, I just recently had a young college football player come to me who had sustained an ankle injury, co-captain on the football team, a linebacker, and he had injured an ankle bad enough that the coach said, take the week off, you're going to miss the next game and maybe 2 games. So the young man came to me, and where he had injured the ankle, you have to understand, when you damage tissues, you damage the energy field around the tissues. So I have a technique where I can blow that damage out of the energy field, and that young man was back in practice the next day like nothing ever happened, and the coach couldn't believe his eyes. He'd never seen that type of thing happen in his entire coaching career. So now, at the end of the season, he wants to get together for lunch, he and his trainer, and talk to me about what I did. But the point is...
Is this part of Qigong, what you did?
Yeah, it was the energy environment around the cells.
Right, but is what you did what you would refer to as a kind of Qigong, almost?
Well, it's working with the energy called Qi. I was invited to be part of a think tank in Canada, and one of the gentlemen who was also invited was a medical doctor from China who was a Qigong master. And after 4 days together, we realized we were talking about the same thing. He talks about Qi. A woman from India there refers to prana. I refer to us being actually the result of 7 higher dimensional information fields. And he looks at me and he says, are we not all talking the same thing? I said, yes, we are. We're just talking apples and oranges here. It's just all fruit. It's the same type of energy. So the only thing that goes wrong with the body, according to him, is you have a blockage somewhere. So anything that interferes with the normal balance, flow, and distribution of energy in this system creates a problem. Well, notice I said balance, flow, and distribution of energy.
Yes.
Energy, highly structured as information. So it's all an obstruction or a corrupting of information or data. That's all that's going wrong with us. We're just slowly but surely getting corrupted like a computer does when it gets a virus.
I want to also clarify something with you. Years ago, I did an interview with many water scientists and pioneers. I had 5 of them on the show at the same time. It was mind-blowing. We were talking about how you can change the frequency of water and you can change the water. In other words, the clinical chemicals won't be harmful. But what does that mean relative to your water and the whole matter of frequency? What frequencies do you put in the water vis-a-vis intent and literally?
Well, these are extremely high frequencies we're dealing with. The frequencies that would normally be associated with the atoms of different elements would be very, very high frequencies up in the terahertz range. Now, trillions of cycles per second. So I'm not particularly concerned with frequency because I know that the most important thing, there's a lot of really expensive devices out there that are based on frequency.
Right.
And they're quite honestly not getting very good results.
Why?
If you step back and understand that we're more than frequency, we are a multiplexing of waveform patterns in vacuum space. We are an assemblage of 7 very complex, what we call scalar fields, which are standing waves in vacuum space. These are informational fields, and we have vacuum space now structuring itself, and that's the fundamental hard drive nature of us as a biological specimen. So it's all about reestablishing the integrity of the waveform patterns. And I've actually developed some technology, and it's doing an amazing job of doing that, particularly emotional stuff. And that's a discussion for a different day.
That's part 2.
Yeah.
The last thing I wanted to ask you is, I've heard you say your water is not electromagnetic. Is that correct?
No, it's not electromagnetic. Now, there was a gentleman, he's dead now, he was in Cheney, Washington. His name was Bruce Tanio. He was the one that developed the device for the company that makes the essential oils, Young Living, down in Utah.
Right.
It could measure the frequency. He was curious about my water, and he said my water had actually a blue-colored aura around it, and instead of being in the megahertz range, the frequency was in the kilohertz range. So it doesn't necessarily follow that the higher the frequency, the better something works or performs, or the higher its function. Frequency and function, basically, there's no relevance. There's no correlation. So there's a lot of misunderstanding there. Everybody thinks, oh, higher frequency better. No, not necessarily. It doesn't necessarily make for more competent function, higher integrity of operation. That's not what it equates to.
I think that's a fundamental key that you just said, because I think a lot of us have been under the newer information, that the higher the frequency of anything, the better. But maybe that's part of the confusion.
Going back to the very, very first part of the interview, that's the problem with science, is making assumptions like that when they may not be true at all.
Dan, it's a great pleasure and an honor, and it's fascinating to talk with you, and I'd like to invite you back for part 2. Would you come back and visit with us?
Oh, yeah, I would love to. That would be great.
Ladies and gentlemen, we have been talking with, learning from, and listening to Dan Nelson, a physicist who's doing groundbreaking work with water and health in Montana. And how may people find out more about you?
There's a lady they can call. There is a private website, but to access the website...
You have to be a member. It's a private membership, correct?
Yep, right. That's right.
Okay.
And all you've got to do is sign a form and agree that we as adults can get together and discuss any topic in any language we choose to.
Very good. Who should we have them call?
I would have them call you.
Okay, call the Rainmaking Company, 626-398-8652. Or you may contact us at timing@rainmaking.com. Dan Nelson, we want you back. I have many, many more questions and discussion points. Thank you so much for your time today. I'm very excited. It's rainmaking time.
Thank you, Kim.